Hi, everybody. I'm so excited to share this lecture with you. I just wanted to pop in, say hello, and for this lecture, since it's so science focused, I wanted to make a slideshow instead because this will help explain things hopefully in a lot more clarity. So this module is all about the microbiome. And I first want to give a shout out to my mentors and colleagues and people that I've trained with who have learned a lot about the microbiome from them. So a big thank you to Dr. Andrea Macbeth, Dr. Heather Zwicky, and Dr. David Lashid for inspiration on this lecture. They've done so much great research in the field of the microbiome. And after attending several of their lectures, this was really just a conglomeration and Cliff Notes version of a lot of the pearls of wisdom that they've imparted on. So let's dive in. So, what is the microbiome? The microbiome is a combination of bacteria, protozoa, viruses, all of that, and yeast that create this world in, on, and around us. Now, certainly in the world of new research today, we're looking a lot at the microbiome in the intestines. But I want to remind us that the microbiome is so much more than just in the intestines. It is on our skin. It is inside the nose. It is in and on our genitals. It is even on the bottom of our feet. So, on our whole body, we have about 3 to 5 pounds of microbiome, which is just amazing. And that's including in the intestines, too. So, there's certainly a lot in the intestines, but we can't forget about the rest of the microbiome in and on us as a whole. And then around us, of course, there's so much life outside of just the microbiome in and on our bodies. We've got microbiome on the surface of our desk, on the lip of the glass you're drinking out of, the plants around us. The whole ecosystem is full of life that we can't see with the naked human eye. So, this is a very exciting time to get to dive into the gut microbiome, because that's specifically what we'll be talking about today, being the gut brain connection. But the microbiome is so much bigger than just the pieces in our intestines. But it's fascinating that the research is showing so much in these tiny little worlds. So just a small history about bacteria and the microbiome. In the 1860s, Louis Pasteur and Robert Koch first showed that bacteria can cause disease. This is where germ theory came from. They're noticing that bacteria can cause people to feel ill, so bacteria got labeled as bad during that time. In the 1870s, sanitation and sterilization techniques were developed because we saw that bacteria can cause disease. So we think, well, we should get rid of the bacteria. Then in 1928, Alexander Fleming discovered the first antibiotic, or first modern day antibiotic, penicillin. And from here, this is where things started to get really exciting. But before we dive into the world of the research and starting to discover more, there are two people that I want to pay homage to for terrain theory. This was also in the 1800s, uh, mid to late 1800s, and then into the early 1900s, where Claude Bernard first came up with the thought of terrain theory, which is thinking about the bacteria in and on our bodies as something where we can hone for balance and homeostasis. And if everything is well balanced and our ecosystem is healthy, then a healthy terrain equals a healthy human. It's not just that the germs are bad, but a whole terrain piece can create more health in a human. And then that idea was expanded upon in a few later years with Antoine Beauchamp, and that's who's pictured on the right here with the bow tie. That is thought about this theory of terrain versus germs. And truthfully, they're all right. Bacteria can cause disease, and a healthy terrain leads to a healthy human. And then in 1995, the first 2 bacterial genomes were sequenced at the Institute for Genomic Research, which is very exciting. The first one was Haemophilus influenza B, also known as HIB. And then the second one is a very small genitalia microbiome. And then in 2003, the Human Genome Project came about. This was so exciting. This was huge. Being able to see DNA sequenced to almost 90% accuracy at that time was really quite the win for science. And this was the tipping point to being able to see into the microbiome with all the detail that we can now and seeing these small structures coming into life. And then 2006, the Human Microbiome Project came around. And this was small at the time. There were 300 quote unquote healthy people that were getting to look into their microbiomes, people ages 18 to 40. And this was really the start of it all. And now it's just budding, and certainly every year, but nearly every month, something new is coming out about the microbiome. The microbiome is influenced by a lot of things. Now, we're scaling it back a little bit now to just thinking about the microbiome in and on the human body. Genetics plays a huge piece of it. Age, where you live, stress levels, exercise, diet is big. We're seeing a lot of pieces coming out here with it's not even just the type of diet that you have, or not even just the food that you eat specifically, but is it organic or versus not organic? If you're having pesticides and herbicides, if those kill bugs and invasive herbs, what could it do to the inside of our bodies? So organic versus non-organic, if you're eating a lot of plants versus if you're eating a lot of animal products, even if you're doing more of a fasting pattern than eating regularly scheduled meals in small amounts, we're showing that all of those have influence on our microbiome. Exercise, whether it's amount, duration, intensity, whether it's outside or inside, all of these play a piece in our microbiome as well. We saw some pieces with the stress levels about gut-brain connection, but we'll discuss that even more in the next lecture here too. And where you live, this is whether you live in the country or the city, whether you live in a home with many people and pets versus if you live by yourself, whether you live in a more developed country or more rustic. These all have big effects on the microbiome. Smoking affects the microbiome. The pets piece is interesting too because it's the type of pets, the amount of pets. How often do you cuddle with them? How are they indoor, outdoor pets? And are you rubbing your face right on their face as well, getting contact into their microbiome? Medications, we think about antibiotics as being big things for decreasing the bacteria in the microbiome. Antifungals would certainly get rid of the fungus there too, and things that get rid of parasites would decrease the parasites prevalence. But it's not just those medications that kind of deforest the microbiome. There is influence on the microbiome with any medication, including supplements. So if you're having herbal supplements, that would certainly influence the microbiome. If you're eating or having supplements that are anything plant-based, that would affect the microbiome. Or even seeing any type of pharmaceutical medication can affect the microbiome too. The work environment you live in, or excuse me, the work environment that you work in, this can be partially the stress levels, but then also how many people are you coming into contact with? Are you inside an office? Are you working at home? Are you outside working construction? Are you a massage therapist that you're literally coming into contact skin on skin with somebody else's microbiome on the daily? All of these pieces have an effect on the microbiome. Time outside and then home environment. Stress levels, pets, siblings, how many people you live with, do you have roommates, and all of these pieces come into contact with the microbiome and have a big influence as well. So why do we care? Why is this important? Dr. Macbeth shared this analogy in one of her lectures a couple of years ago, and I just thought it was so good, so relatable. So back in the 1920s in Yellowstone National Park, this actually happened within the park. And I think it's a great analogy of a macrocosm of how this could happen with microcosm of what's happening in our bodies. In the 1920s, they were thinking the gray wolf is causing too much havoc at the park. It's our apex predator. We should get rid of the gray wolf. So they did. And it triggered a whole ecosystem change that actually changed the course of the flow of the water in the parks just from the change of one species. So without the gray wolf as the apex predator, coyotes became the new apex predator. And with coyotes, they eat antelope and red fox and rodents and some birds, and they noticed that the population of those animals came down. And then the gray wolf normally fed on elk, and without the gray wolf, elk population exploded. And they were overgrazing on willows and aspen and caused a lot of overgrazing in the park. But then the willow and aspen that the elk were eating, that's the primary food for beavers and their primary shelter and what they used to build dams. And so the beaver population virtually disappeared. It went down to just one pod of families, one colony. And then the beavers weren't there anymore, so the dams started disintegrating, and what used to be marshy ponds turned into streams because there was more water flow there. And that also affected a lot of plants and animal species. This was just from one change at the top of this food chain. Then in 1995, the Endangered Species Act said, we need to reintroduce the gray wolf. So they did. And coyote population got cut in half. That allowed more antelope and more rodent and more fox to flourish. And then the elk population also went down because the gray wolf was their main predator. And that helped with the aspen and the willows. And then the beavers were able to come back. What went from one colony bloomed to 12. And then the change of the flow of the river went back to how it was pre 1920s. I think this is fascinating. And this is a macrocosm. If we change one thing in the microbiome, it has an effect on our whole system. Something that we're seeing, which is a little bit of doomsday to prepare yourself, is that as we're becoming more industrialized as humans, we're seeing a change in the diversity of our microbiome, where the diversity and robustness of our microbiome is decreasing. As you can see on the graph here, if you live in the jungle or the savanna, the microbiome has a lot more diversity. And then it goes stepwise down as you get into more rural areas, and then even more so in urban areas. And we're also seeing not only correlation, but we're seeing some causation too with more modern diseases. We're seeing more obesity than we've ever seen. We're seeing more prevalence of asthma and food allergies, diabetes, even cognitive disorders. And we're seeing, well, perhaps there's just a correlation, and it might be, but we're also seeing that the microbiome has a huge play in this change of modern diseases and decreased microbial diversity. Now, the one piece that I like to really remind people of is we can't grow this back. Once we lose the microbiome as a human species, or once we decrease its diversity, it's very hard to get it back. We can increase the amount of the existing microbial species that we have, but without other interventions, we can't get back what we've lost. So it's very important to keep a healthy mouth. The microbiome doesn't just affect our gut health, it affects almost all systems in our body. It affects the immune system, it affects our brain and behavior and our stress response, our HPA axis, which is hypothalamic pituitary axis. It's in our brain into our adrenals, and how well we respond with cortisol and stressful responses. It affects our heart, it affects our blood flow, and it, of course, affects our metabolism and nervous system in our gut specifically. So, that enteric nervous system that we've been chatting about. This is a short list of the microbiome and disease patterns that we're seeing. And this is a big list, but it's not complete. There are a lot more patterns that I just didn't put on here because they're not as common. So in the world of gastroenterology or digestion, we're seeing a correlation of the microbiome with IBS and Crohn's disease, ulcerative colitis, even non-alcoholic fatty liver disease. We're seeing patterns there. With metabolism, we're seeing patterns with obesity, type 1 and type 2 diabetes. In autoimmune, we're seeing a pattern with chronic fatigue syndrome, rheumatoid arthritis, psoriatic arthritis. We don't think about the joints having an effect with our microbiome, but there certainly is. And then in the neurology sphere, even Parkinson's and Alzheimer's, these are really coming to the forefront in the last 5 years. The anxiety and depression we've talked about a little bit already, but we'll dive into a lot of the neurology pieces in the next lecture. And then we're seeing patterns with immune system too. So not just autoimmune, but UTIs and antibiotic resistance, these more like infectious type things. COVID too, especially long COVID. And this is just a small smattering of why the microbiome is so important and why we want to keep a robust, healthy diversity. So the gut-brain connection is what we're going to dive into in a lot more detail next. This is a small schematic of what this looks like. We've got the central nervous system, and which is in our brain and spinal cord, and that connects to our enteric nervous system, which is specifically in the intestines. And then the connection between the two is the autonomic nervous system. So all of those pieces talk to each other through the vagus nerve, through the HPA axis, through the immune system. And we'll get to talk all the details on how this affects secretion, motility, mood, stress, and cognition in the next lecture.